We're talking about pump design, but not in the abstract, not from the whiteboard in some downtown office. We're looking at it from the field. Because when you're standing on a lease, watching that pump cycle irregularly, or trying to figure out why downstream lines keep corroding even though you're doing all the right things, that's when this stuff matters. Let's set the scene. You've got a horizontal producer, maybe it's in the Montney, maybe it's Permian, maybe it's somewhere in northwest Alberta. But the problem is the same. That well is producing fluids, gas, maybe some fines, and the pipe runs horizontal for hundreds or even thousands of meters before it kicks up to surface. Now here's what happens. Flow slows in those horizontal sections. Liquids settle, solids drop out, gas breaks through intermittently, you've got terrain-induced slugging, unstable flow, building up slugs of fluid, followed by gas voids. That cycling repeats over and over. And here's the part that matters to you, the person in the field. That flow instability downstream of the perforations is driving some of your biggest headaches. It's surging solids into your lift system. It's gas locking or short cycling your pump. And worst of all, it's sending slugs of entrained solids downstream into pipelines that were never designed to handle that kind of abuse. So what do? Well, that's where downhole pump design, intelligent, terrain-aware pump design, starts to show its value. And leading the way is a system called the HEAL system, short for Horizontal Enhanced Artificial Lift. The idea is deceptively simple, but the results are game-changing. Here's how it works. The HEAL system gets installed just above the heel of your horizontal section. It acts like a downhole traffic cop, stabilizing the chaotic flow coming out of the lateral before it ever hits your pump. Instead of just letting gas and fluid slam into the intake all at once, HEAL uses cyclonic separation and flow conditioning to deliver a smoother, more consistent mix to the pump. Gas gets vented, fluids get metered. The pump runs longer, steadier, and with fewer shutdowns. And you get fewer midnight callouts and way less solids downstream. In fact, some field data shows production increases of 20 to 100%, and pump run life extensions up to 5 times longer when HEAL is deployed. Not because it changes what's coming out of the rock, but because it manages the way it flows to surface. And here's the kicker. That stable inflow, it prevents solids mobilization. No more rapid surging that scours out fines, no more sandpacks launching like bullets down the line, just consistent, managed production. And that changes everything for your downstream system. Why? Because solids are the secret saboteurs of pipeline integrity. They don't just erode elbows and plugs. They trap batch inhibitors. They absorb corrosion chemicals. And when they lodge in low flow zones, they create microenvironments where corrosion rates skyrocket. We're talking 50 to 250 times higher than baseline. So instead of reacting to leaks and wall loss, we can prevent the risk at the source by never letting solids get loose in the first place. But it's not just HEAL that makes the difference. Field operators are also getting ahead by optimizing tailpipe length and intake placement. You don't want your pump pulling from a slug zone. You want it installed downstream of the worst terrain drops, where flow is steady and clean. By engineering your pump placement to avoid terrain traps, and by using flow-stabilizing tailpipes, you reduce gas locking, cut back on scale formation, and extend the life of both the pump and your flow lines. Even something as simple as adjusting your tailpipe ID can influence velocity, help solids settle where you want them, and protect the system from unexpected surges. Let's wrap it up with this. Pump design isn't just about getting fluid to surface. It's about controlling the type of flow that reaches your pump, and everything downstream of it. It's about cutting solids at the source, minimizing corrosion risk, and giving field teams fewer alarms, fewer callouts, and fewer failures to chase down. If you're in the field and fighting recurring corrosion, short pump run times, or unpredictable production volumes, it might not be your chemicals, it might be your flow profile, and the solution might already be downhole. This has been another Trusted Pipeline Advisor Deep Dive. Stick with us for more stories from the field and the tools that help you stay one step ahead.